Hi guys, I'm just starting to go through some of the questions from Lab 1 and I'm going to try to do up in these little video clips for you. Not going to be too long, probably just a minute or two each, but in case anyone has any troubles with any one particular part, hopefully this will help clarify things. So, the first question was asking you to determine which of the sets it should be N, Z, Q, or R a number belongs to. Now, N is a set of natural numbers. Z is a set of integers, Q is a set of rational numbers, and R is a set of real numbers. So a couple of things we have to remember before we even start this is that if something is in the set of natural numbers, it's automatically in all the other sets too. Same with integers. If something's an integer, then it's not necessarily a natural number, but it will be a rational number and a real number. If something's a rational number, um, it it may or may not be an integer or a natural number, but it'll always be a real number. And if something's a real number, then it could be any of the above ones. It could be a natural number, it could be an integer, could be a rational number, but it doesn't have to be. So just keep that in mind as we're thinking through these. So the first one we'll take a look at is minus 4.5. What sets does minus 4.5 belong to? Is it in the set 1, 2, 3, etc. on up to infinity? No, it's a negative number, so that means it's not a natural number. Is 4.5 an integer? No, it's not an integer, so we know it's not that either. Is it a rational number? Well, it can be expressed as a decimal point that's either terminating or a repeating decimal. So yes, it is indeed a rational number. And because it's a rational number, it's also a real number. So 4.5 minus 4.5 belongs to the set Q and the set R. Now you can write that out a bunch of different ways. If you even picked just the set Q, I was quite happy. So that's for the first one. The next one is going to be the square root of 5. So the square root of 5, well, we can go through the same sort of routine. Is it a natural number? Is it an integer? Is it a rational number? Or is it a real number? Well, when we go through looking at it, uh, we can evaluate it to see what it is. The square root of 5 is 2 point, I'm not really sure what exactly, but it's not a natural number because it's at least has a decimal in it. It's not an integer because it has a decimal in it, and because it's a square root of a number that doesn't have a full square to it, it automatically means that it's not a rational number. So it's the n digits aren't going to repeat. So it's a non-terminating, non-repeating decimal. Therefore, it has to be only a real number. How about the number 4? Well, number 4 happens to be a natural number. It's in the set 1, 2, 3, 4, etc., etc., etc. So that means it belongs to the set of natural numbers, and by default has to be in the real numbers, the integers, and the quotient. So it's actually in all 4 sets. How about minus 45 over 47. 47. So minus 45 over 47, it's not a natural number, it's not an integer, but both numbers are real numbers on top. So we know it's going to be in a real number set, so we're good there. Is it going to be a rational number or not becomes the question. And in this case, it will be because we will have either a terminating or a repeating decimal when we actually work this all out. So this belongs to Q and R. And finally, minus pi over 5. What will that be? Well, pi over 5, pi happens to only fit in the real number. It's 3.141 and the number goes on forever. So it can't be represented as a rational number. Because pi itself is an irrational number, that means that when I divide pi by 5, or if I multiply by -1, I still have a number that's not a rational number. But is it a real number? Yes, it is. So that does belong to the set of real. Now I did leave one out there. It wasn't on purpose. I left out the square root of -6. Now in this case, the square root of -6 is not going to belong to any of these sets. It's sort of the trick question that's in the group. It's not it's not a natural number. It's not an integer. It's because of the whole square root part. It's definitely not a rational number. And because we're getting the square root of a negative, that means it's not a real number either. So it doesn't belong to any of the sets. It actually belongs to a different set of numbers that we don't really cover that are called imaginary numbers. But I really don't want to get into the whole imaginary number thing because it's well beyond the scope of what we're doing. With that being said, that's it for question 1. I'll move on to do the next couple of questions as we move forward. Hope you find this useful. Bye for now.